screen. I think my voice is audible and screen is visible to all. The last part of first chapter, that is the overview of advanced manufacturing processes. In previous lecture, we have discussed the comparison between conventional machining and non-conventional. Now, in this lecture, we will give a brief review or overview of advanced machining process, that is a non-conventional machining process. See here, advanced machining process, it is having the same meaning like a non-conventional, non-traditional machining, right? In first part, we have covered core machining, is the basic principle how they work. These are the 5 machines we have to cover under the first part. That is the first one, water jet machining. Second, abrasive jet machining. Third one, that is the abrasive water jet machining. And fourth one, that is the ultrasonic machining. These are the 4 types of the machining which are based on a mechanical energy. Means the first 4 types, these are come under the category of non-conventional machining based on mechanical energy. We will see in detail its construction, working, application, chapter wise. The first chapter, which is a non-conventional NCM process based on mechanical energy, where you have to study these 4 processes in detail. EDM, it is the electrical energy based process. Now, as we discuss about the mechanical energy based process, the first type of the mechanical energy based process is a water jet machining, right? And these are the some sample pictures that will show how the machining is to be happen under the different type of the machining processes, non-conventional machining. If you are considering, this will be the water jet machining process. Here, this will be the soil. This will be the wood, right? Lakud, right? And this will be the pipe which is having a nozzle at the tip. So that high pressure water, when come out from the nozzle, it will produce the high velocity of water jet. And that high velocity water jet, when it will be strike on this workpiece, right? So material is to be removed by the striking action of the water particle, high velocity water particle. The material is to be removed from the surface of the workpiece by the action of erosion, right? Material is to be removed from the surface of the workpiece by the action of erosion. So in this manner, this water jet machining is to be carried out. Then second, abrasive jet machining. Here, abrasive jet machining. In abrasive jet machining, we are not providing only water. We are providing certain abrasive particles plus air or inert gas. We may call inert gas as well as air. The mixture of air plus abrasive jet, it will be passing through this nozzle. So at the tip of the nozzle, we are getting high velocity abrasive water jet, abrasive air jet, right? So that, what is abrasive? These are the small particles of the metals. Those are having sharp tip sharp edges. Some metal particles, those are having the sharp corners. Such particles are called as the abrasives. That abrasive mix with the air, and that mixture of air plus abrasive, when it is passing through this nozzle, we are getting high velocity jet, and that high velocity of jet, when it will strike on the surface of the stone, it is a brittle and hard material, right? The material from the stone, it will be removed by the process of erosion. Now this central process, it is a combination of these two processes, abrasive jet machining and water jet machining, where we are passing the abrasive particles along with the water, so that we are getting the abrasive slurry, right? And that slurry, it will be striking on a surface of the stone, and material is to be removed in the form of small metal particles, ions, molecules, right? Because mechanical action. Which mechanical action? Erosion. Erosion of the material is to be takes place. How does it work? The kinetic energy of water or abrasive particles makes it to happen the removal of the material from the surface of the workpiece. How much is the velocity of the water jet or abrasive jet? It is near about 900 meter per second. Whatever the water, it will be coming out from the water jet machining process. Its velocity, it is a very high, as much as near about 900 meter per second. That much velocity of water when strike on a surface of the workpiece, definitely the material is to be removed because of the action of erosion action, right? So this slide, it will be dealing about mechanical energy based process, where material is to be removed by the process of erosion. Write the name of each process, draw this block diagram, and write this short note about this mechanical energy based process, that is water jet machining, abrasive water jet machining, and abrasive jet machining. Take a 5 minutes to complete this task. Is it over? Now, the fourth type of a mechanical energy based non conventional process, that is the ultrasonic machining. In ultrasonic machining, this will be the tool. It will be act as a transducer and it will be vibrating over this ceramic surface. Ceramic is a very hard material, hard as well as brittle, right? To machine such a material, it is quite difficult by using the non-conventional machine. In order to remove the material from the ceramic, which will be the hard and brittle one, we require the tool, and this is a tool. It will moving or vibrating over this surface of the material, and in between this material and the tool, abrasive plus liquid, that abrasive slurry, it will be combinedly called as a slurry of the abrasive. It will be passed between tool and the workpiece. It is called as a carrier, right? Why it is called as a carrier? Because this slurry, it will consist of these abrasive particles, these blue color particles. These are the sharp edge metal particles. As a vibrating action is going on such particles, these particle dip out the material from the surface of the ceramic, and whatever the material it will be removed, it also carried out when this abrasive is flowing over the ceramic. So it will be called as a carrier. No doubt this abrasive particle remove the material, but the slurry of this, it will carry out the removed particle from the surface of the ceramic. So this is the ultrasonic machining process. It is a type of the mechanical energy based system. So in mechanical energy based system, that is the first chapter, second chapter, where we have to study these four processes. Hello, हाँ बोला. लेक्चर मध्ये बुक पाठवतो मी. You take some time to draw this diagram. That will clear, I think, try to clear your concept. uh, it will be shown block diagrammically. Okay, I think this will be over. Now, next type of the non-conventional machining, it is based on electric energy, that is the electric discharge machining process, right? Where we're using workpiece, and that workpiece and work material both must be electrically conductive one, right? What is the main criteria for electric discharge machining? It is the energy based, electrical energy based system where we require the electricity, right? And that electricity it is passing through this workpiece and through this tool, right? Where positive terminal always connected to the workpiece, so it will be act as an anode, and negative terminal it will always connected to the tool or electrode. It will be called as a cathode. And to transfer that electric current from anode to cathode, or in order to complete this circuit, we require some medium, right? And that medium is nothing but the water or kerosene, or it may be called as a dielectric fluid. What happens when we are maintaining certain distance between this electrode and the workpiece, right? Sparking it will be takes place, right? And in electric discharge machining, because of the sparking, high heat it will be generated at this gap, and because of increasing in temperature, the material is to be removed from the surface of the workpiece. This is the servo control tool. Its movement is carried out by servo mechanism, and it consists of workpiece and tool. Both are the electrically conductive material, and because of the sparking and plasma, the material is to be removed from the surface of the workpiece. You draw this block diagram. It is for the electric discharge machining, and it is a electrical energy based system. Okay, is it over? This is the first part. Anyone have any difficulty regarding the how these processes are to be work regarding its block diagram, its working principle? समजतंय का? Hello, please reply. Raviraj. Hello, anyone?
Yes, sir.
Okay, thank you, Mahesh. इंटरॅक्टिव्ह बरं वाटतंय सेशन का बोर होतंय राजांनो? हॅलो.
सर आता हे लास्टच लेक्चर आहे, बोर व्हायला लागले.
Okay. Okay, many of the people they will join the lecture at the end session, right? I observe it. So that you write your attendance right now. Write your roll number in chat box. It will be considered as attendance on 4-7 p.m. The strength of the student from your class, that is BEA, that will be very less. For why it will be happen? For all lectures are only elective subject. Yes, Mahesh. 20% students are also only will be present for the class. Only 20%. Okay, no problem. Now, the second part, in which we have discussed about the some of the process which are based on thermal energy, which are based on chemical energy. In electrical energy process, there are two processes: electro discharge machining and electro discharge grinding. Right? Those are having the same principle. Now, in the second part, we are focusing on laser beam machining, that is the LBM, plasma arc machining, PAM, electron beam machining, EBM, ion beam machining, that is the IBM, electrochemical machining, and chemical machining, CH. If you are observing this diagram, the first type, where this plasma, laser, electron, ion, these are come under the category of thermal machining, thermal energy based machining, and these two are come under the category of a chemical energy based machining, chemical energy based, electrochemical machining and chemical machining. So the first part or first type of the thermal energy based machining, that is the laser beam machining. See here how it will be carried out. In childhood, we may do one activity that we are taking one lens, and that lens kept in sunshine. So sun rays that will be passing through this lens, and that rays are get concentrated. And when that concentrated rays are put on a paper, the flame is to be generated. The same principle it will be using in case of a laser beam machining. If you are considering the block diagram or setup of the laser beam machining, this will be the laser gun. This will be the laser beams. And by using this lens, all these beams are getting concentrated at one point on a workpiece. When this high velocity laser beam, they are strike at a one particular point, the heat it will be generated, and because of that heating, the melting and evaporation at particular space it will be carried out, and that will be the responsible for removing the material from that particular location. If you are observing this setup, then your idea it will be clear that how this laser beam machining process is to be carried out. See, mechanism of metal removal, that is the melting and vaporization. Whatever the material is to be removed from the workpiece, it is because of a melting or vaporization of the workpiece. For difficult to machine materials, high thermal conductivity, high reflectivity, aluminum and copper, very low machining efficiency. Okay. If the material which is having a high thermal conductivity, like aluminum, copper, those are thermal conductive material, right? To machine such material, it is quite difficult in case of the laser beam machining, right? So the efficiency of such machines it will be a very low. This is the setup for the laser beam machining. You draw the setup diagram or block diagram for laser beam machining. Okay, let's move to the next process, the plasma arc machining. it will be the same like a laser beam machining, where we are generating this plasma arc with the help of electric energy. Means this will be the combination of the two energies. We require the electrical energy, and the electric energy is converted into heat energy, and by because of the heat, the material is to be removed from the surface of the workpiece. Means it is a combination of electrical as well as thermal energy. Here gas is passed through this nozzle. This will be the electrode. When this gas is coming out from this nozzle, this plasma arc, it will be generated over here. For that purpose, the distance between the nozzle and the workpiece, it will be kept at some standard distance away from each other, so that plasma it will be generated, and that plasma it is having a very high temperature, near about 1000 degrees centigrade, and at such high temperature, the material it will be get evaporate or it may get melt, and because of that, the removal of the material from the workpiece, it will be carried out. This plasma arc machining process also can be used for softening of the workpiece by heating using plasma arc, and after that machining is to be carried out. This is the block diagramical representation of plasma arc machining. This will be the plasma. We supply the electric DC current. This will be the electrode, and this some neutral gas. It will be inert gas. It will be passing through this nozzle. So when by keeping sufficient distance in between nozzle and the workpiece, the arc it will be created or plasma is to be generated, and that plasma is having very high temperature, and that will be main source to remove the material from the work. Draw the diagram, block diagram for the plasma arc machining. Okay. The next process, it is like a laser beam machining, right? Only instead of laser, we are passing the electron beam, right? So in electron beam machining, in short, it is called as the EBM machining, where we are using this tungsten filament in order to emit some electrons from that filament, right? When that electrons are passing out from this electron gun, this is the electron gun, this is a hot tungsten filament which will emitting the electrons, and from this electron gun, this electron beam, it will be produced, right? And to produce that electron beam, we are using certain kind of a magnetic lenses as well as certain beam control coils. They are shown in this over here. These are the electromagnetic lenses and these are the electro control coils, so that whatever the electrons emitting from this tungsten filament or from this electron gun, they are produced in, they are emitting, coming out from the gun in the form of beams and striking at a particular location on the workpiece. But one care you must have be taken in case of a electron beam machining process, that whatever the process is to be carried out, the workpiece and the tool or the mechanism, it will be having a vacuum chamber. It is having a very high vacuum, means electron beam machining process. It is the one kind of a thermal energy based process, but that process is carried out in a vacuum. The chamber where vacuum is to be there, that high vacuum chamber, it is having a vacuum of a 10 raised to minus 5 mm of Hg mercury. That much lower vacuum you have to produce, high vacuum, sorry, you have to produce in a machining chamber of a electron beam machining. So this will be the block diagram, right? Transmit the electron, you have to provide the supply or provide the voltage across it. It is near about 10 raised to 5 volt. Then and then only electrons are to be emitting from the tungsten filament. Complete this diagram within a minute. Okay. The ion beam machining, it is on the same phenomena of a laser beam machining and a electron beam machining, where we are producing some ions. That ions are produced and that will striking on a surface of the workpiece. When atoms come under the outer boundary, then they will be converted into ions. And when that ion striking on the target, so material is to be removed. So this will be the ion beam machining. Now, another type of machining, that is the electrochemical machining and chemical machining. It is based on a combination, that is the electric energy and chemical energy. I think slide is somewhat blur. I will replace it. In electrochemical machining, when you are observing this diagram, in electrochemical machining, you must require workpiece and tool. Both are electrically conductive because we are supplying electric energy. Low voltage, high current, you are passing through this workpiece and the tool. And the workpiece, it is submerged in an electrolyte solution. So it will be a conductive of a electricity. And we have to remove the material from the workpiece. The shape of the material you have to generate on a workpiece. The same replica of that shape, it will be is on tool. Means whatever the shape you want to produce on a workpiece, it will be a square shape, round shape, or any irregular shape. That shape, it must be, the tool must be of that particular shape, whose impression you have to mark on that workpiece. And this electrochemical machining process, it is as like a electrolysis process, which will be based on Faraday's laws of electrolysis, where we require electrically conductive workpiece. Then and then only material is to be removed from the workpiece. And the tool which you are using, it is having a whatever the tool shape, it's a replica, it will be generated on a workpiece. It is all about the electrochemical machining process. And electrolyte, it is a solution. It will be the complete the bridge between tool and the workpiece. Now last type, that is the chemical machining process. In chemical machining process, whatever the portion of the workpiece from which you have to remove the material, that portion of the material, it is exposed to the chemical only. Chemical is nothing but the etchant. Etchants are the chemicals. And the remaining portion of the workpiece, it will be covered with a maskant, that is the insulating solution, right, or barrier between chemical and the workpiece. So whatever the surface of the workpiece which will be exposed or in contact with the etchant, that is the chemical, the material is to be removed from that particular surface because of the chemical action. So by using the chemical reaction, we can remove the material from the workpiece. It all about the chemical machining process. Just draw the block diagram for electrochemical machining and chemical machining. Okay. In this way, in today's lecture, we have covered the overview of all non-conventional machining process we have to study under this subject, that is the non-conventional machining. This is the first chapter we have covered up till now. Now the second chapter, it is a completely based on a non-conventional machining process, which are based on mechanical energy. Means mechanical energy based non-conventional machining process, where you have to study four types of the machining processes, that is the abrasive jet machining, abrasive water jet machining, and ultrasonic machining. Each machine you have to study in detail in the next chapter. So we will stop over here. If anybody have any query related to the overview of this non-conventional process, please feel free to ask me. समजतंय का? एक अंदाज आला का कुठल्या कुठल्या प्रोसेसेस आहेत, कुठलं वर्किंग प्रिन्सिपल आहे आणि कशा पद्धतीने मटेरियल रिमूव्ह होतं? Yes, anybody have any doubt? Is all concepts are clear? Okay, anyone have to write the remaining to write the attendance? Please write it in chat box. So we will stop over here. We will meet in next week with a new chapter, second chapter, mechanical energy based non-conventional processes. Right? Any doubt, Yogesh? 41, roll number 41, Yogesh. Have you left the meeting? Rajiv, Raviraj? Shweta?
Yes, sir.
Okay, overview of the machining processes. Is it clear? Are you
Yes.
understood? Okay. We'll stop over here. Thank you.